Diverging lenses. Diverging lenses are thicker at the edges than in the center. Diverging lenses make parallel light rays diverge. The focal point is the point where the rays would converge if the rays were projected backwards. The image created by a diverging lens will be examined for 3 different object positions: outside the center of curvature, between the center of curvature and the focal point, and inside the focal point. The ray tracing rules for diverging lenses are different than those for converging lenses. All images are virtual. The rays diverge after passing through the lens and do not focus on that side. The first ray enters parallel to the principal axis, passes through the lens such that if the diverging ray was reversed, it would pass through the focal point on the same side as the object. The next ray enters the lens on a line connecting the object and the focal point on the other side of the lens. It exits the lens parallel to the principal axis. This will be easier once we actually start drawing the rays, but we'll go through them now, but it'll be better once we're drawing them. Number 3, the last ray goes through the center of the lens and is not deflected, which is the same as my favorite ray from the converging lens rules. Number 4, all rays are then reversed to converge at a point on the same side as the object, giving us a virtual image. All right, here's that first ray. It's parallel to the principal axis, then it hits the lens. At this point, you're going to trace back a line that goes through the focal point. The real light ray goes off that way. However, we're tracing it back, and that is the reversal of the diverging ray passing through the focal point. The next ray enters the lens on a line connecting the object and the focal point on the other side of the lens. It exits the lens parallel to the principal axis. So here you can see this purple line is aiming towards this focal point, but as soon as it hits the lens, it then goes parallel to the principal axis. This time, we'll stop with just 2 rays. The rays do not intersect on the real side. However, if we reverse the diverging rays, we get a virtual image right here. You can see this image is demagnified, virtual, and upright. All right, now we're moving the object closer to the lens. Now it's between the center of curvature and the focal point. The first ray is going parallel to the principal axis, and when it hits the lens, it's going to diverge. But if you dash it back, it would go through the first focal point here. The next ray is going to aim at the far focal point, but as soon as it hits the lens, it will then go parallel to the principal axis. We'll use all 3 rays this time. The last ray goes straight through the center of the lens. Once again, the rays do not converge on the real side of the lens, but if you dash back all the diverging rays, they form an image here. And you can see that image is larger than it was when the object was really far away. But the image is demagnified, virtual, and upright. Now we move the object in front of the focal point. So the first ray is going to go parallel to the principal axis, and then it's going to diverge, and it's going to go back. If you dash it back, it'll go through the focal point. So that's the same first ray as the other 2 scenarios. And just the same as before, we're going to aim at the far focal point, but as soon as the ray hits the lens, it will then go parallel. And once again, we do not get a real image. These diverging rays do not converge on the real side. But if you dash back the diverging rays, you get an image, a virtual image. The image is demagnified, virtual, and upright, although you can see that the image is larger than when the object was farther away. All the images are demagnified, virtual, and upright. Once again, you don't have to memorize tables of information like this. You just need to know how to draw a ray diagram. A candle is located 15 centimeters away from a diverging lens that has a focal length of 30 centimeters. Draw a ray diagram and describe the image formed in terms of real or virtual, location, and magnification. All right, so because the focal length is 30 centimeters and the candle's located 15 centimeters, that means it's going to be inside of the focal length here. So we draw our object, we draw our first ray, we aim it through to the focal point on the other side, but as soon as it hits the glass, we then go parallel to the principal axis. Then we have one that goes parallel and then traces back through the focal point. And so you can see that these rays intersect here. So this one went parallel, then we trace it back to this side, and then this one went off like that. It diverged away, but then we trace it back. And we see a virtual image right here that's smaller. It's demagnified. It's virtual since it's on the same side of the lens as the object, and it is upright.